The whole idea of AI agents, large language models that are able to do things for you autonomously, is so brand spanking new that frameworks like LangChain, CrewAI, and Swarm, and especially no-code agent builders, aren't actually good enough for mature and production-ready AI agents without you having to put in a lot of additional work. But with Pydantic AI, things are starting to change in a lot of really incredible ways. Pydantic AI is an open source Python agent framework that makes it a lot less painful to develop truly production grade agents. It implements a ton of really important features that are often overlooked in other frameworks for agents. We got things like context management, error handling and retry logic, testing and evaluation capabilities, logging and monitoring, large language model output validation, just to name a few, and this list goes on. Pydantic AI is incredible and it is so easy to use, but in a lot of ways, building an agent with it is not actually my focus in this video. What's really important for you and what I'm going to be focusing on is the how. How is Pydantic AI actually making it possible for you to more easily build production grade agents? Because in the end, any framework going forward needs to implement all these features that I'm going to cover in this video, and you have to know how to leverage them. So that's what I'm going to show you right now. I'll show you what I mean first by heading on over to the Pydantic AI documentation and blowing your mind there. Then we'll build an agent from scratch with this framework so I can show you how easy and powerful it is. Let's dive right in. Alright, so I promised that I'd blow your mind with the Pydantic AI documentation, and so I'm going to live up to that right now with a quick overview of all of these features that I've already talked about, and then we'll go and build an agent. But first of all, Pydantic itself has been around for a long time. It's essentially a validation library in Python. And what I mean by validation is this. Let's say you're building a fast API endpoint, for example. Fast API is actually built on top of Pydantic. Well, you have all these endpoints that expect specific information, specific payloads to come into the endpoint. And Pydantic is that validation layer that makes sure what you expect to come into your endpoint is actually what you receive. And similarly for large language models, like with OpenAI and Anthropic, you can see right here that they have Pydantic as their validation layer. You expect oftentimes specific input from the large language model or specific output if you're working with structured output. So certain keys in JSON, something like that. And Pydantic is that validation layer to really ensure that you're getting that structured output that you are expecting. And so yeah, like I said, OpenAI and Anthropic use it, LangChain, Llama Index, CrewAI, all these other things that I referenced at the start of the video as well, they all use Pydantic as the validation layer. Now this team is who are going ahead and making Pydantic AI, and so that's why I really trust them and make something beautiful here, because they have validation at the core of what they believe in, and that's one of the big things that a lot of these other frameworks don't focus on. They don't focus on validation for the output of LLMs, or testing LLMs, or working with your tools and making sure you're invoking the right tools. All these things, they all have to do with validation. So that's why I'm really excited for Pydantic AI. So let's cover some of these features really quickly here in the documentation. First of all, it's model agnostic. They have all these different providers that you can use, and you can even add some yourself. So later in this video, I'll show you how to use a Pydantic agent with Ollama so it can be 100% local. It's type safe. They've got structured responses and stream responses. That's what really leverages the classic Pydantic under the hood. They have a type safe dependency injection system. This is how you can manage context for your agent. Important things like database connections and API keys, which a lot of frameworks don't have. And this is super useful also for testing and evaluation as well, because you can have mock dependencies for your agents. And they also have Logfire integration for debugging and monitoring. And there's a video down here I want to show really quickly that gives you a sense of what this actually looks like. It's just so robust, the way that you can set up a Pydantic AI agent and then have this entire UI to show you what's going on with all your LLM calls and tool calls. It is just amazing. And then they got some other examples in the documentation here, like showing how you can use different providers. Like boom, I just say I want to use Gemini 1.5 Flash, and it automatically knows to go to Google for the provider. And if I switch this to GPT-4o, boom, we'll be using OpenAI under the hood. So it integrates with all these different providers. And then we have the tools and dependency injection. So like right here, my agent needs a customer ID and a database connection. These are the kind of things that my tools might need that I don't want to actually give to the LLM to pass as an argument to the function. So a lot of times with other frameworks, you have to call your tools manually and add in these extra parameters, but you don't with Pydantic, because your agent session has these things tied to it. And also, to tie a tool to your agent, you just have to say this agent right here that I defined very simply above has this system prompt and it has this tool, and then you just attach the function to wherever you put this decorator, like right below. You define the function, and boom, now it's able to invoke this tool. You don't have to do it manually, and every single tool call is going to have that extra context that you passed in here, like your API keys and whatever. Just so easy to set it up. And there's so many other things as well. Like if we go into the results here, it's really easy to get the information from your result, to get the cost, any other sort of metadata. They have chat history and messages. You can get the entire chat history after any call to a large language model. They have a ton of stuff for testing and evaluation that is so useful. Like being able to have a test model. So you don't actually have to call a large language model to run your unit or integration tests, because you never really want to pay real money when you're running your tests. And so it's just so important. And then they have a ton of examples here. Some of them actually get quite complicated, but a really basic one right here is they have a weather agent. So if you're looking to really quickly understand how to build an agent with Pydantic AI, I would suggest going to their weather agent right here. Because it shows you how to set up your context here, like the weather API key and your client, and then you define your agent, you define your tool to get the latitude and longitude like this. And then, by the way, the doc string is what tells the LLM when and how to use your tool. Then you define another tool for getting the weather. That's a bit of a longer one right here. And then you have your main function. And this is where you create your dependencies, which is that context for the agent. And then you call it, and that's it. And you can set up conversation history, all that good stuff that I'll show you later as well. So easy to use this framework, but you get all these other things that other frameworks don't normally have. And so with that, let's dive into actually creating an agent with Pydantic AI. So for this demo of Pydantic AI, we'll be building a web search agent. It's one of the hottest kind of agents right now. It's just so important to connect your agent to the real world with web search. And we'll be doing this with the Brave Search API. It's one of the best APIs for browsing the web, and it's free to use to get started as well. And so I have the documentation up right here. I'll be referencing this a couple of times as we build the agent. Again, it's not the main focus of this video. The main focus is just showing the power of Pydantic AI and the kind of things that you want in a framework to build production grade agents. But it's also a cool little tangent here to show you how to use this API. So that's one of the prerequisites, along with Python, having an OpenAI API key if you want to use GPT, like I'll be using in this video, and then also downloading Ollama if you want to run local LLMs with Pydantic AI, like I will also be doing in this video. And all of this code that I'm about to cover here, I'll have a link in the description to my GitHub repository, where you'll have all the code that I'm going to be creating with you here, as well as instructions on how to run everything yourself. So this README that we're looking at right here will be available for you to make it as easy as possible to follow along with me, run this yourself, and extend it yourself. And so with that, let's dive into creating the code. So the only thing I have in my Python script right now is the skeleton for a main function. We really are going to be building this Pydantic agent from scratch together right now. The only thing I've really set up at this point is my .env file. So you'll see this .env.example file in the GitHub repository. You just want to set your API keys and the model that you want to use, and then rename it to .env, just like I outlined in the instructions right here. And so, by the way, the model I'm using right now is Qwen 2.5 Coder 32B. So we will be using Ollama for the demonstration in a bit once I have this agent fully built out with you here. And so the first thing that we're going to do is import all the packages that we need right here for our agent. And then we can load our environment variables and define the large language model that we want to use. And to get things ready for Ollama, if we choose Ollama, we're going to create a custom asynchronous OpenAI instance where we override the base URL right here to point to localhost port 11434, where Ollama is currently running on my computer. And then what we do is define the model, that the actual instance that we want to run based on the value of the large language model environment variable. So if it starts with GPT, that means we're just going to use a base OpenAI model, not with the overridden base URL. But if we aren't using GPT, then I'm going to use this custom client that I set up, because I'm assuming we're using Ollama at this point. And so if I have LLM model defined as something else like I do currently, like Qwen, then we'll be using Ollama. Next up, I'm going to configure Logfire for that amazing logging and monitoring that's included with Pydantic AI. So this is actually optional. If you don't have this set, it won't configure Logfire, but it'll still work. And I'm actually not going to configure this right now because I want to keep this tutorial concise and simple. Just know that it's really easy to set it up with this code right here. And then after this is where we get to define our dependencies for our agent. And so the client right here, this is our dependency for the client that will be browsing the web. And then we have our Brave API key. And so this way, every time we call a tool with our agent, it's able to access these two things which we need. We don't want to tell the LLM, oh, here's the Brave API key to give to the tool, because we don't want to have to pass our credential into the large language model call so we would know what to give as that parameter. So we have that as a dependency so it can still be used by the tool but doesn't ever have to be given to the LLM. So I hope that makes sense. But then moving on here, this is where we get to actually define our agent, and then we bind the tools to it subsequently. So we have the model that we want to use, which is going to be either pointing to Ollama or OpenAI. We can define our system prompt here, which is a pretty basic system prompt. The one thing I do give it is the current time so that it can include that in more recent web searches. And then I give it the dependencies, telling it to expect a client and Brave API key. And then also model retry. This is something that's so important that other frameworks don't include. I can tell it, like, if there is an overload error, like we see with Anthropic all the time, it can retry another time before it actually fails. And so super, super useful. And then we can define our tool to actually search the web. And so we just have this decorator here where I reference the name of my agent, and then I say .tool. And then I define this function here where it accepts, first of all, the context, which is what we have right here. And then also a parameter that the LLM will define, which is the query. What does it actually want to search the web for? And then we have our docstring that tells the LLM when and how to use this function, what arguments to give and what to expect from it. And then we can go on to define it. So first of all, if the Brave API key is not defined in the context for whatever reason, like maybe we're just testing this function out, then we can return a test sample message right here. Otherwise, we'll move on and start setting up the API call to Brave. And so we define the headers that are required. And again, you can go and reference the Brave API documentation to figure all this out, or even just ask GPT or Claude. It can help you with these things, which is super neat. So we define the headers, and then we start basically a section of Logfire here, so that we can have this dynamic logging and we can have these different sections to see, oh yeah, this is the section I click when I want to see what happened in the tool call to Brave. And so within this Logfire span here, we are going to use the client that we have as a part of our context, this HTTP client, to call the Brave API with all the parameters and headers with our API key that we need. And then we just get the response and then finish off this section of our Logfire logging. And so now with that, we can massage the results that we get into what we want to output for the LLM. And so this is basically just taking this fancy JSON that we get back from the Brave API, turning it into what we want to tell the LLM, and then returning that. So whatever we return here as a string is what the large language model gets back to then reason about and give the final answer to us. And so that is the end of this tool right here. And so now in the main function here, we get to actually define the use of our agent. And so I start a new agent here. I define the dependencies for it with my client and my API key, which I just get from the environment variable, obviously. And then all I have to do is say my agent.run, and then I give it my prompt and the dependencies, and boom, that's it. You can also attach chat memory here if you want, which I'll show in a little bit for another demo. And that's it. We get the result, and then we print it out. And we can also use this debug library that Pydantic uses in their documentation, so you can see everything that happened, all the tool calls and stuff that got to the response that we'll eventually see with this last print statement right here. And that is it. We just got basically like 100 lines of code right here. We have this full web search agent. It's pretty basic with how it uses the Brave search API. But just know that there are a lot of other endpoints they have as well, where you can summarize results, for example, from a bunch of web searches. You can do image search as well. So you could take this example that I have right here and create a bunch of other Brave tools to do image search in all the different ways that you need. Because right now, this search is mostly helpful just to get specific articles, for example. So the question for my demo here is going to be, give me some articles talking about the new release of React 19, which came out just this week, by the way. And so it'll give me some articles, but it's not actually going to go into the articles and give me research from those, but you can do that by extending what I've built here with the Brave API. So with this, let's go ahead and try it out. Running this thing is super easy. I'm currently in the directory for Pydantic AI where we have the Python script, and all I have to do now is run the command python and then web search agent.py. And this is using Qwen running locally on my computer, so it's going to take a little bit here, but it'd be even faster with GPT. But still, you can see it's pretty fast here, and you can see that it's telling me when it's running the search web tool, it's getting the result and now reasoning about it, and boom, here is our response. Here are some articles discussing the new release of React 19. Very pertinent to my question here, and then it gives me 3 articles that I can go check out right now. Click on any of these links, and there we go. Did some web research for me. And then because we have that debug that I showed earlier running, we have the entire history of what's going on here, like with what the tool returned to me and the tool call that I chose to make. Absolutely perfect. So this thing is working really, really nicely. Now this is the base agent that I want to show you how to make. I also have another version in the GitHub repository where I created a Streamlit interface, so an actual UI with chat history, so you can interact with this agent in a more robust way. So I'm not going to show coding that one from scratch, but I'll quickly show you the code for it and then demo that one as well. So last up, I wanted to show my Streamlit version of this agent that we just built together. And it's a little bit more in depth, so I'm not going to cover building this one from scratch because I don't want this video to be 45 minutes long, but I want to show this really quickly because it implements some of the other really cool features of Pydantic AI. The first one being chat history. With that other agent, we just sent a single question into the agent, and it's not like we could repeatedly chat with it, but with what I'm going to show right here, you actually can. I also implemented text streaming, and so we'll see in typewriter style the output coming out from the LLM in real time, so we don't have to wait for it to fully finish its response before we can start reading it. And so one thing I will say is Ollama doesn't seem to support streaming with Pydantic AI. So right now I'm just using GPT-4o for the model, but it's still really cool to see this, and I'm assuming that there's just some disconnect between how the OpenAI compatibility of the Ollama API works with Pydantic that stops this from happening. Not totally sure there, but anyway, we're using GPT-4 for this. I have this function set up that uses my agent. So I extrapolated some of what we had in the web search agent.py script into my Streamlit UI to execute the agent running this stream command right here. And then I pass in the message history. So you can see that as a parameter to this function to call my agent, I give the entire message history. I take the latest message content as the current prompt, and then everything except the latest message as the history. And so that's how I get the response with chat history, and I just yield each chunk as they come from streaming the LLM output. And then within the main function right here, I display all the chat history in the UI. I take in a prompt from the user chat input, and then I manage the state. So I add the user message to the current state of messages, and then I add the response to the state when I get that back. And then I just use asynchronous operations here to call prompt AI, get that response, and then display it in the front end. So super, super basic. And then this second script that I have, the Streamlit version of the agent, is basically the same thing that we already coded, just with the parts taken out of it that I have to run within the Streamlit UI right here. And so with that, we can go ahead and run Streamlit and try this out. All right, let's test this thing out. It's basically the same agent what we had already, but I don't have to define the question in the code. I can do it here in the UI. I get streaming, I got chat history, and it's also using GPT-4o, so it should be a little bit faster as well. I mean, it's really cool that I was using Qwen. I wish I could here too, but it'll also be nice to get something a little bit faster here. So let's start with the same question here. I'll say, give me some articles for the new release of React 19. All right, and so you can see it's running in the top right, getting me my response. There we go, we have it streaming out. This is looking really, really nice. All right, cool, cool. And then, yeah, so because it has chat history, I can say, what did I just ask? And if chat history wasn't working, it would have a totally wrong answer here, but here we go. You asked for some articles about the new release of React 19. Perfect. So now let's ask, what is the net worth of Elon Musk? Let's see if we can get this answer as well. So yeah, searching the web as of December 2024. Yeah, surged past 300 billion. So I asked this question in my Flowwise video as well. I just think it's nuts how rich he is. It's pretty crazy. He's got a little bit of change to spare. But yeah, this is working absolutely beautifully. And also the Streamlit UI, it just makes it so easy to build something beautiful really fast. So I love using Streamlit in my videos as well. But yeah, Pydantic AI, this thing is just the GOAT. I hope that you found this video super informative. It is just so important to stay up to date with the latest and greatest. Not necessarily so you can just use the hottest hottest framework for the month. I mean, none of us like switching like that, but more so just so you can understand the direction that we are heading as an industry as we get more advanced with our AI agents and truly understand what goes into making them production grade. There are so many features with Pydantic AI specifically that are crucial and often overlooked, and it's your job as a developer to understand what is needed for these frameworks, make sure you choose the right ones, and also know how to leverage all these things to make things enterprise level. If you appreciated this content, I would really appreciate a like and a subscribe. And with that, I will see you in the next video.